And coming up next, we have Chris P. with SoftLayer Technologies, talking about IPv4 address conservation within hosting networks.
Hi everyone, I'm Chris P. I'm a network engineer at SoftLayer Technologies. Together with my boss, Win Tim, we came up with an idea for IPv4 conservation method that we are going to employ in our networks. So the issue that we run into is that we have, when we bind a subnet to an interface, we waste 3 IPs just naturally with the network gateway and broadcast addresses. Sorry, this is my first time. If 1 or 2 servers are assigned to subnet, the most common allocation that we have to give is a /29. But when we do this, we end up wasting more IP addresses. And in fact, in this scenario, we waste now 6 addresses. We have our 3 that we normally wasted, plus the 3 that are unused in the subnet. And that might not seem like a lot of addresses are being wasted, but whenever you start doing this across multiple routers, you see that you start exhausting addresses quite quickly. And in markets like APAC and Europe, where the maximum allocation is a /22, it eats up space pretty quickly. So here we see an example of what I'm discussing. You have customer A, which has 2 servers in a subnet, and you have customer B, which has 2 servers in a subnet. They both have /29s, and so here we've burnt basically 12 IPs. And so what happens whenever one of the customers grows and adds more servers? Well, most likely they won't do it immediately. They'll do it after a few months, which means we won't have a contiguous block to assign them. So what happens is now we run into this issue. We have to give them a whole other /29, and this is just for the same customer, and depending on how many servers they actually add, we end up burning even more IPs from unused space. And then what happens if you need a first hop redundancy protocol, such as HSRP or VRRP? More addresses get used, and even though that might not seem like a big deal now, what happens in a number of years whenever you go to broker to receive more IPs? So the solution, move to IPv6. We've been dual stacked for a while, and the problem is you just can't make everybody else move to v6, and so you have a dependency still on v4. Is there a more efficient way? Why does it have to be a publicly routable IP? The only place where the gateway address is actually used is as a link local address for servers to get the MAC address and the source IP for the router directly connected for host communication. The actual forwarding of packets destined for the remote networks don't actually reference the v4 address. So here we looked at which ones we could use non-routable space. We could use RFC 1918 space. We could use RFC 3927 space, but we believe the best choice would be RFC 6598. Why not RFC 1918? Well, it was published a while ago in '96. You're probably already using it elsewhere in your network for out-of-band management or whatnot, and it can potentially confuse ops staff and customers to see that on their publicly facing interface. Also, why not RFC 3927? Well, if you do try to use it, a lot of systems with DHCP clients will automatically configure themselves into this space. And this kind of runs into a problem of manageability. You lose control of what addresses are being used where. So is it okay to use RFC 6598? It's actually reserved for carrier-grade NAT, but we believe in our scenario that you can use this, and if it's configured properly, it shouldn't interfere with other uses in your network. And in fact, provisioning system should allow it, and you can design a small part of this block just for this purpose and reuse it on other routers. I'm not going to do the best movie voice thing, but imagine it in your head. If there is still a demand for v4 addresses from your customers, you have a few options. You could turn them away and then just not make money. Use some sort of NAT gateway, but especially in a hosting environment, that becomes costly because you need to do one-to-one NAT. A lot of our, obviously, ports that are being used are 80 and 443. Or you can go to a broker and buy some IPs. Going to a broker, we see that cost of IPs are probably going to go up. There was recent press about Microsoft purchasing Space from Nortel for $7.5 million, which worked out to $11.25 an IP. If all the RIRs are out of IPs, the price of IPs will be a lot higher, obviously, because the supply is gone. Let's say that you have a router that has 1,000 SVIs, and each SVI has a primary and a secondary address block on it. Each block is going to use 3 IPs just for network, gateway, and broadcast. And if you do the calculations, you find that you're basically wasting $67,500 on just burnt address space. If you have a big network, it can get even more expensive. So how does our concept work? Well, adding one of the subnets will cause unicast RPF to allow traffic sourced from the subnet. So you need to have an ACL that prevents this. Do not advertise the space into your IGP, or at least tag it so it doesn't get exported into the global routing tables. Most OSs will support binding a /32 to the interface. Windows 2003 will require you to use the NetSH instead of the GUI. And your router must be able to support static routes to an interface. So here we have our initial configuration. Again, same scenario, we have customer A and customer B. We only need to allocate them a /30 because the servers themselves don't need to have an IP bound to them from the 100.64 space. As we scale, we can see that we're just static routing more and more IPs /32s directly to the interface. So we're not burning any more IPs for network gateway and broadcast address, and we certainly don't have a large subnet bound that has unused IPs in that subnet. So we'll go through the configuration steps. First, you want to configure your routing policy to prevent the link local gateway from being advertised. You want to update your outbound ACL. You want to configure your router interface and configure your server. So routing policy update, this is a very basic Cisco example. Just create your prefix list, create your route map to match it, and there you go. You need to update your ACL to be more specific if you don't have unicast RPF configured. This ACL is very strict, and it will not allow you to ping your gateway, but ARP will still work. This is so that customers on different interfaces on the same router can't ping each other's gateway. You can modify this if it's too strict. Here's a basic Cisco example of an SVI configuration. Pretty straightforward. You have your access group configured on there. You have your /30 configured on there. And then you see that we static route a single /32 to the SVI. Here's the same example again, but with HSRP. On a server config, we're going with the CentOS example, pretty standard Linux kind of thing. You're just going to bind your /32 to the interface. You're going to add a static route routing the gateway address to your interface, and then obviously you're going to set it as your default gateway. But wait, there's more. This will allow you to allocate a single /32 to your customers with no IP raised, and you can still allocate a /29 or larger and statically route it to the interface, and all the IP addresses will still be usable. There are additional benefits to this. Basically now, instead of having to create ACLs, which would block your gateway network and broadcast address from being hit from external targets, you now have a naturally kind of built-in mechanism because you're using non-routable space. You have some caveats. Even though your router may have a huge fib, you need to validate that it can handle a large number of static routes. If there is a lot of server-to-server communication, you're going to need to do some additional configuration on the server, maybe to point the other server's IP directly to the interface the same way you did the gateway. At SoftLayer, we don't experience this problem. We have a back-end network for server-to-server communication, and it's a routed network that spans our entire network globally. There are some techniques to allow the different subnets in the same layer 2 to talk, and again, that's going to require server administration, and that might not be preferable. So all of our examples are in Cisco, and Juniper is king in your shop. There's currently not an option to static route a subnet to an interface. We've spoken with our Juniper reps, and the engineering requests are open. If you would also like this feature, we encourage you to bug your Juniper rep. There's our ER number, so you can just bug them and give them that. There's other vendor support. As part of our next generation hardware testing, we've tested some gear from Arista and found an interesting feature. Their multi-chassis link aggregation support allows for unified forwarding plane, so there is no need for the active backup concept in the other first hop redundancy protocols. Their layer 3 redundancy is called a virtual ARP, and you bind a shared gateway IP between both chassis, but they are both active and they respond to ARP as the gateway. This allows you to implement the methods described in this presentation, but also allows for an interesting technology refresh option. The functionality allows for an upgrade path from single chassis or unified control plane hardware configuration to redundant hardware using separate control planes without affecting customer IP allocation. Here's a configuration example of a single chassis SPI. The problem when converting this to a first hop redundancy protocol or HSRP is that most vendor implementations require you use IPs within the subnet that you're using. So now what you have to do is you have to go to your customer and ask for them to give you back IPs. So here we can see our attempted configuration on a Cisco. You can see it actually will take it and it will complain, but then when you look at the actual HSRP state, it'll show you in an interface down and it'll tell you it's the wrong subnet for the interface. Here we tried it again with Juniper, and again, all the way up until you try to commit, it'll take it, and then as soon as you commit, it'll complain about the IP not being in the same subnet. Now here's the virtual ARP example with Arista's EOS. You can see that you statically configure a MAC address, and in fact this example can work if you'd like. And then you can add your 100.64 space like you normally do, and then you have your virtual router address. And then you can also static route your /29 or whatever subnet to the interface. So we've discussed this with a couple of different vendors, and it couldn't hurt to get additional support from the community. So if this seems like an interesting option, bring it up to your account team. And that's it. I talk really fast. Does anybody have any questions?
Scott Librand, Limelight. So it sounds like this requires some unusual configuration on behalf of your customers in configuring their servers, in that they have to configure a gateway that's not in the normal subnet. You gave an example of CentOS and it works fine there. Have you seen any examples of customer equipment that doesn't support this? Is it an additional support headache to get customers to explain it to them, to get them to configure it and all that?
So at SoftLayer, we have an automated provisioning system. So whenever we provision the server, it will be set up with the IP, the gateway, and the static route for the gateway already. So far, we haven't run into any problems with the different OSs that we've tested. As I mentioned, Windows 2003 requires NetSH, but 2008 and 2012 will both allow you to do it through the GUI. And then we've tried Debian, CentOS, Red Hat, even FreeBSD. They all seem to take the configuration just fine.
Okay, I missed the part that you guys were doing the configuration for the customers. That makes sense.
Sorry. Yes.
Hello,
Hi.
Donnie Roisman with SoftLayer. Did a great job. I just wanted to also point out that one of the reasons that we're talking about this is still kind of an experimental phase. We've proven it works. We haven't used it very widely, but we're very eager to hear back from anyone else who may have tried this, who is trying this, who's already run into some problems or pitfalls, people who think this is interesting, sexy, exciting, and want to do it themselves and want more information, et cetera. So if you've done anything like this before, if you've already eliminated this as an option, please, we have a few minutes now. It'd be nice to bring it up and open up for discussion.
Okay.
You talked a little bit about how you're dual stacked V6, but not getting the greatest uptake. Do you have any strategies for browbeating customers into uptake? It was interesting compared to that John Curran's slide about the number of ISPs who don't yet appear to have V6 allocations.
In the hosting environment, our customers are going to be the end users, the eyeballs. And so really as the eyeballs networks start to adopt V6, we'll probably see a greater uptick on V6 utilization. But until pretty much all the eyeballs are updated to V6, we're going to have a dependency on V4.
Lee Howard, Time Warner Cable, Eyeball Network. I talk a lot about that exact chicken and egg. I'm gonna talk about it again tonight or this afternoon and again tomorrow morning. Eyeball networks have more motivation to deploy V6 if there's content available over V6. We should be able to walk and chew gum at the same time.
Sure.
Let's not wait for each other. I actually like what you're doing here. This is, this looks pretty clever. My first response when you said 100.64 was to say, oh, come on, that's, and then I looked at it and said, yeah, you know what? As long as you're using it internally and I never see that route, I don't care what address block you use. You can use any address block internally, and that's just fine. It's your network. So, no, this is good stuff. Thanks.
Excellent, thanks. Okay, excellent. Well, thank you all.
Thanks, Chris.